We have here the ball and stick model for propyl acetate. To figure out the molecular formula, we'll first count the carbon atoms. We can see we have 1, 2, 3, 4, 5 carbon atoms. So we'll begin by writing C5. We'll go and count the hydrogen atoms now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we'll then write H10. And then finally, we have 2 oxygen atoms, O2. Next thing we need to do is draw the Lewis structure. So let's just go ahead and begin at the far left here. We'll draw this carbon. And each stick represents 2 bonding electrons. So we'll go ahead and draw those with the proper atoms attached. Okay, now we have this carbon, and again we have these sticks that represent bonding electrons, 2 hydrogens, and another carbon. Again, we have these 2 hydrogens bonded, and this time we have an oxygen bonded over here. And the oxygen is bonded to a carbon. And one thing the ball and stick model doesn't show, but the Lewis structure will show, are lone pairs that are attached to oxygen atoms. So here we have this carbon that is double bonded to an oxygen atom above it. And we will go ahead and give this oxygen atom its lone pairs. And then we have this carbon is bonded to another carbon atom, and that is bonded to 3 hydrogens. We are asked to draw the structural formula, and that's pretty much the same idea as the Lewis model, except what we're going to do is we're going to replace the bonding electrons with lines. And we will not show lone pairs. The next thing that we are asked in this question is to identify the functional group. And the functional group is found in this case in the center of the molecule. So the functional group is right here. And this set of atoms bonded in this manner are what characterizes an ester functional group. And finally, typically esters have a sweet and often fruity smell. So we would expect this molecule to have a sweet smell.